Hi, everybody. Hope you are doing well. And we are continuing the explanation of polymerization of or synthesis of polymers. Let's remember first that polymerization can be addition mechanism or a condensation mechanism. We already started the addition, which can be by free radical, cationic, or anionic. We already finished free radical. We will have some examples later on free radical, and today we are going to talk about cationic polymerization. So the cationic polymerization is one of the chain growth polymerization reactions. In that case, we will have a cationic initiator, which will transfer its positive charge to a monomer. And once a monomer becomes positive, it will be reactive and can attack more monomers to grow up the chain of the polymer. The monomers that can undergo the cationic polymerization, either olefins or heterocyclic compounds. Because guys, olefins have double bonds. So this double bond can be broken by an initiator, okay, and then form the required ion, which is cation, carbonium ion. Heterocycle has a cycle which can be opened to form the carbonium ion or the positive ion. These are some examples of the cyclic compounds. Of course, cationic polymerization is very sensitive to the type of solvent used. So we have to be very careful when we choose the solvent in which the reaction will be carried out. Because we don't need a solvent that can dissociate and trap the positive ion of the monomer. We need this positive ion to continue and to attack more monomers for the polymer chain to grow. But if the solvent has an ion which will trap the carbonium ion, the initiator, the reactive monomer, so the reaction will be terminated before it starts. So it's very important to be careful while choosing the solvent. These are examples of polymers that are synthesized by cationic polymerization, like polyisobutylene and poly-N-vinyl carbazole, PVK. Then, what are the steps of cationic polymerization? Cationic polymerization is an addition reaction, addition mechanism. So normally it will have three main steps. As we mentioned before in the free radical, we start with initiation step, which will initiate the reaction, and then a propagation, and this is the longest step in the reaction where the polymer chain is increased in length. And once we get the polymer that we need, we have to terminate the reaction or make termination to get the full chain of our polymer. So our steps, as usual, as an addition reaction, cationic has three main steps: initiation, propagation, and termination. The initiation, this is the first step of the mechanism where a carbonium ion is formed. Carbonium ion is a compound with a carbon atom carry a positive charge. The counter ion should be non-nucleophilic. In the medium, there will be a counter ion, but it shouldn't be a nucleophile because nucleophiles are rich in electrons, as you know. So if I have a substance which is rich in electrons in the medium, it can trap the carbonium ion and the reaction will not proceed. It will stop here. It will be terminated in the initiation step and no polymer will be formed, of course. Also for initiation, an electrophilic initiator can be used to help forming the carbonium ion. And this carbonium ion will initiate the propagation step. What can be the initiators? The initiators can be a classical protonic acid or a Lewis acid with the aid of Friedel-Crafts catalyst. The classical protonic acid should be low molecular weight, uh, should be used for low molecular weight polymers like phosphoric acid and sulfuric acid and all of the classical protonic acid. So this way of initiating the reaction, this initiator is used when we need a low molecular weight polymers. The protonic acid will dissociate into proton, okay, and a negative ion. If you have this is the acid, the protonic acid. So it will dissociate into the proton and the negative counter ion. So this proton will attack the monomer, the olefinic polymer, for example, or the cyclic monomer, and then it will break the double bond, leaving a positive charge here. And this is the carbonium ion. And once this formed, this will initiate the propagation. So this is the initiating monomer. This is the reactive monomer, which will start the propagation and start the reaction, the overall reaction of polymerization. For the Lewis acids and Friedel-Crafts analysts, these are the most common compound for initiation. And example of these like aluminum chloride, boron fluoride, titanium tetrachloride, and so on. In the case of Lewis acid, in the presence of Friedel-Crafts catalyst, as a catalyst, so the Lewis acid will react with water, forming this compound, and the positive charge, the proton, and a counter ion. Then the positive charge of the proton will attack the olefinic monomer, and then the bond will be broken, leaving a positive charge here. And a counter ion will exist in the medium, but this counter ion is not nucleophilic, so it couldn't trap the carbonium ion. Also, carbonium ion salts can be used as initiators, and ionization radiation can initiate the reaction. For the carbonium ion salt, as usual, the positive the positive ion will attack the double bond, leaving a positive charge on our monomer. And this carbonium ion is formed, which make the monomer more reactive and ready to attack more monomers. Another way to initiate the cationic polymerization is by ionization radiation. And that case form a radical cation pair. When our monomer is exposed to radiation, the double bond is broken, forming a radical cation. So here we have a carbon, which carry a free radical, and the other carbon carry a positive charge. Okay, so this radical cation pair will react with a monomer and will attack the double bonds, forming a cation and a radical. When the reactive carbonium ion is formed, when the reactive monomer that has a carbonium ion is formed by initiation, it takes its way into the propagation. So it will attack another monomer and transfer the positive charge and then attack another monomer, and the chain will grow by adding more monomers. By adding more monomers, we have a positive charge here, which will attack another monomer, okay, forming also a positive charge, and so on. This is the propagation. This is the longest step in the polymerization reaction, where more monomers are added to the chain, and the last monomer will carry the charge. After propagation, termination will take place by, first, we have many ways of termination. One of them is a chain transfer, the chain transfer. And this chain transfer happens by hydrogen abstraction to the counter ion. So we have a positive charge. The terminal hydrogen will combine with the counter ion, and a double bond will be formed, and the polymer is formed and the reaction is terminated, giving back the initiator. Like the initiator can be the protonic acid, for example, or by hydrogen's abstraction to the monomer. So in that case, another monomer will abstract this hydrogen, and the polymer will form a double bond, and the reaction will be terminated, giving back another carbonium ion. Another way of polymerization is the cationic ring opening to terminate the reaction. So termination by cationic ring opening, this is a complete mechanism, polymerization of a cyclic compound using a protonic acid. The proton of the protonic acid will attack the monomer, forming a positive charge on the functional group and a counter ion which is not or non-nucleophilic to avoid the trapping of the positive charge. Then another cyclic monomer will be attacked by the reactive monomer, and the cycle will be opened here, and the other cyclic compound will bind to the reactive monomer. And then another cyclic monomer will be attacked by the positive charge, leading to a cycle opening and an addition of an extra monomer, and so on until forming n monomers which are bound together. At the end, there is a cationic ring opening with methanol. The pair of the electron will attack the positive charge, leading to opening of the ring. Okay. And the polymer is terminated. The polymerization is terminated. So to recap what we have today, we explained what is the cationic polymerization is. A cationic polymerization is a type of the chain addition or the chain growth polymerization reaction. The chain growth reaction polymerization is a reaction where the chain is grown up by adding more monomers in a step called the propagation step. Addition polymerization has three main steps: initiation, propagation, and termination. In initiation, a reactive monomer is formed. In our case, in cationic polymerization, the reactive monomer has a carbonium ion, which carry a positive charge. Once it is formed, it starts to attack more monomers, and the chain is increased in length until the reaction is terminated. The cationic polymerization can happen for olefins or cyclic compounds. We need an initiator to initiate the reaction, which can be a protonic acid, and this is less common, or a Lewis acid with the aid of a Friedel-Crafts catalyst, and this is most common. That's all for today, guys. Thank you so much. See you next video, and bye-bye.